Hello, welcome to In 5 Minutes. Again, there is a next problem based on the AC analysis. Question tells us to find the value of AVS, that is considering the source voltage Vs. Now in this case, you can see VBB is providing base emitter voltage of 0.7 volts in DC analysis, that is forward biasing the base emitter voltage in the DC analysis. Again, type of transistor N, P, N. Which type of configuration? Since we are giving input to the base, we can take the output from the collector if it is not given in the question, but if it is taken from the collector, we can call it as common emitter configuration. Now what we need to find out in this is the voltage gain. Again, you can see over here early voltage VA is given as 50 volts. That means we need to consider RO in the circuit. So what this specifies, you need to consider the early voltage resistance RO in the analysis. Now our step 1, what is the step 1? Draw the circuit under DC operating condition. Now what are DC operating conditions? Now if you see, there are no capacitors given in the circuit, but our step is open circuit all capacitors, and second step is we need to short circuit AC sources. So when you are short circuiting AC sources and open circuiting the capacitors, so how the circuit will look like? You can see here the voltage source is replaced with a short circuit, and you can say you are considering DC voltage, you are considering DC voltage. Now what is our step? We need to find out the Q point. So what we'll do, we'll apply KVL to base emitter loop. What will be the equation? IBQ will be VBB minus VBE divided by RB. Is there any resistance over here? No, so it will be only RB. So what will be the value? VBB is 1.2 minus VBE on, if it is not given, we are taking it as 0.7 divided by 50k. So you will get IBQ as how much? 10 microamperes. So we have got the value of IBQ. So once we know IBQ, we can find ICQ. Beta is given as 100. So 100 into 10 into 10 raised to minus 6 will give you the value of ICQ as 1 milliampere. Once you know ICQ, what you can find? You can find the resistance required for the AC analysis. So R pi value you can find out as beta Vt upon ICQ. So what will be beta Vt upon ICQ? Beta given as 100, Vt we are taking it as 26 millivolts divided by ICQ 1 into 10 raised to minus 3. So you will get R pi as 2.6 kilo ohms. Right? Once you can find R pi, you can find the value of GM as ICQ upon Vt. ICQ is 1 milliampere, Vt is 26 millivolts. So you can find the value of GM as 38.5 unit, you know, milliampere per volt. You have got the value of GM. Similarly, you can find the value of small RO. Equation for RO is VA upon ICQ. VA upon ICQ. VA given as, how much is the value of VA given in the equation? 50 volts divided by 1 milliampere. So you get RO as 50 kilo ohms. So we have got all the resistance and conductance which are required for the AC analysis. Now what we do, we go for the next step. What is the next step? The circuit, we need to draw the circuit under AC operating conditions. So what are AC operating condition? We short circuit DC sources and short circuit capacitor. So when you are short circuiting the DC source, it is connected to ground. Here you had VBB which is short circuited. So this is the circuit under AC operating condition. So after this, what we do, we just replace the transistor which is hybrid by equivalent circuit. So RB, RC will remain as it is in the circuit. So when you redraw the circuit, it will look like this. R pi between base and emitter, voltage across R pi is V pi. You have GM V pi between collector and emitter. You have RO, since VA is given in the question, and RC. The question is to find AV. How we find AV? VO upon VS. Now in this case, as I have told you, we can redraw the circuit as GM into V pi. Instead of two resistance, I can draw a single resistance, which is combination of RO parallel to RC, across which we are finding the output voltage VO. Now in this case, the current flowing is in this way, and we are applying KVL from this point to this point. So when you apply KVL to output, what will be the equation? VO minus, or we are going opposite to the direction of current, so plus GM V pi into RO parallel to RC equals to 0. So you can write VO as minus GM into V pi RO parallel to RC. You still don't substitute any values until and unless you are left with only resistance or transconductance on the RHS.